This is podcast 3.3 for chemistry, and we're still going to talk about naming and writing ionic compounds, except we're going to add in transition metals. So the first thing are the rules and how they change. The first part where it says name the metal, that doesn't change. That's always what we've done, and remember, don't change the name. So it still stays as just lithium or sodium or potassium. This is the new part. So the new part here is if we have a transition metal, we're going to have to use a Roman numeral in order to tell the charge. Because if you look on the back of your laminated periodic table, what you're going to see under the cations list is all the transition metals. And you're going to see that some of them have more than one charge. So for example, if you looked up iron on the back of your laminated periodic table, you're going to see that it could be either a +2 or a +3. Or if you looked up copper, you're going to see copper could be a +1 or a +2. We need to use Roman numerals so that we can tell whoever is going to read this which of the metals we used. Was it the iron that was a +2 or was it the iron that was a +3? And if you need a refresher on Roman numerals, here they are. So 1 through 10, that's as far as we're going to have to go. And then the last step still stays the same, where you name the nonmetal and you give it the "ide" ending. So, some practice problems with this. Iron is one of those transition metals that we just talked about. So, to figure out the charge, because I need to know what is the Roman numeral that I use, because this is going to be iron, something, and then chlorine becomes chloride. Well, I need to know what that Roman numeral is. So to do that, you think chlorine has a -1 charge all the time, but I have 2 of them. And a -1 times 2 would be an overall charge of -2. So if this side is -2, then this side must be a +2. And since I only have 1 iron, that iron must have the +2 charge. So I would put a 2 in Roman numerals there. So this is iron 2 chloride. If I go to this one, this is FeCl3. Chlorine's still a -1. But I have 3 of them this time, so a -3 has to be balanced by a +3. So this one must be iron 3 chloride. So you have to use the ending nonmetal in order to figure out the charge on your transition metal. Lithium and then fluorine. Lithium is not a transition metal, so I don't have to take the time to figure out the charge. We always know lithium is a +1, so I just do my normal naming rules where I keep lithium the same and I put the IDE on fluorine. So lithium fluoride. Pb is a transition metal, and it's lead. So lead, something, and then oxygen would be oxide. So what I'm going to do is oxygen is a -2, and I have 2 of them, so that's overall a -4. This side must then be a +4, and since I only have 1, that must be lead 4 oxide. Copper is another transition metal, so copper, and I'm going to need a Roman numeral, and S is sulfur, which will become sulfide. Okay. Cu, I know S is a -2 and I only have 1 of them, so this side has to be a +2, but I have 2 coppers, so each copper must be a +1. So this is copper 1 sulfide. You have to think, what times 2 would give me the +2 I need there, and that's a 1. All right, magnesium. Magnesium is not a transition metal, so this is just normal simple naming rules. Magnesium iodide. And then my last one here is copper again. So I'm going to need another Roman numeral. And then oxygen would become oxide. So oxygen, -2, there's only 1 of them. This side then must be a +2, and since there's only 1 copper, this is copper 2 oxide. So let's practice going the other direction. If I'm given the name, I need to remember that charges must cancel. So trying to get to 0 again. It's nice when you're given the Roman numeral because you automatically know the charge. A lot of people mess up this way. They forget that this is the charge. They think it's the subscript. So they would want to write this as Fe3N. They think that that's the subscript. Remember, that is not the case. So this is not correct. 3 means the iron has a +3 charge. Then we go look at nitrogen. Nitrogen has a -3, and a +3 and a -3 add up to 0. They cancel each other out, which means I just need one of each, so it's just Fen. Chromium in this case has a +5 charge. Oxygen, if I look it up, is a -2. Well, there's nothing I can multiply -2 by that's a whole number to give me 5. So I'm going to look for what they both go into, and that number is 10. I need 2 of the +5s, and I need 5 of the -2s in order to make 10 on both sides to get them to cancel. This will then be chromium 2 oxide with a 5. All right, lead with a 4 charge. Chloride is chlorine, which has a -1 charge. I need 4 of those to balance out my +4. So Pb, I need 1 of them. Chlorines, I need 4. Sulfur is a -2. This copper is copper 1, so it's a +1. I need 2 of my coppers to balance out my sulfur. So Cu2S. And the last one here, iron 2 bromide. Iron with a +2 charge. Bromine always has a -1. I'm going to need 2 of those to cancel out my iron. So it's FeBr2. All right, make sure that you can figure out the charges on those transition metals, and also make sure you know when you need to use the Roman numerals with your transition metals. Make sure you know what those are.